At the World Economic Forum in Davos, most cameras were focused on geopolitics, inflation, and climate pledges. Leaders debated wars, trade routes, and the future of the global economy. But behind closed doors, something far more consequential was quietly confirmed. Meta, a company many believed had fallen behind in the artificial intelligence race, revealed that its newly formed Superintelligence Lab had already delivered advanced AI models internally. No product launch, no flashy demo, no public benchmarks. Just a statement that may ultimately redefine the global AI hierarchy. Those internal systems are known as Avocado and Mango. And if early signals are accurate, 2026 may be remembered as the year Meta re-entered the frontier of artificial intelligence. Not loudly, but decisively. To understand why this moment matters, we need to rewind. Just 1 year earlier, Meta's AI reputation was under pressure. LLaMA 4 suffered delays, internal restructuring, and growing public skepticism around its benchmarks. Meanwhile, competitors like OpenAI and Google appeared to be accelerating faster, capturing developer mindshare, enterprise contracts, and global headlines. Analysts openly questioned whether Meta's open research philosophy had become a strategic weakness rather than a strength. For the first time in years, Meta was no longer shaping the AI conversation. Mark Zuckerberg's response was not incremental. Instead of refining existing teams, Meta rebuilt its AI strategy from the ground up. Billions of dollars were redirected toward compute infrastructure, custom silicon, and elite talent acquisition. A new internal unit was formed with a single mandate: build frontier-level artificial intelligence. Fast. This became the Superintelligence Lab, launched quietly in mid-2025, and backed by resources normally reserved for nation-state projects. 6 months later, Meta's chief technology officer confirmed the lab's first results. His description was understated but telling. Models, he said, were very good. In Silicon Valley language, that phrase implies production-grade systems, not experiments, but foundations built to scale. Avocado is the first of these foundations. It is a next-generation model designed for text, coding, and structured reasoning. Internal evaluations point to strong instruction following, logical problem-solving, and code generation. But Avocado's defining feature is efficiency. Rather than chasing size alone, it appears optimized for lower compute costs per task, a critical advantage as AI moves from demos into everyday use. Unlike many competitors, Avocado is not built primarily as a public API. It is designed to live inside Meta's ecosystem, powering moderation systems, advertising optimization, developer tools, and future assistance. Mango targets a different frontier. It is a multimodal system capable of understanding and generating text, images, and video. This places it in direct competition with emerging cinematic AI and video generation platforms. But Mango's promise is not just visual quality, it is integration. Text-to-video creation, automated editing, real-time creative assistance, embedded directly into platforms used by billions. This is where Meta's advantage becomes undeniable. OpenAI may dominate cultural awareness. Google may control search. But Meta controls distribution at historic scale. Facebook, Instagram, WhatsApp, and Messenger together reach more than 3 billion users. When Meta deploys AI, it does not need to find an audience. The audience already exists. Behind these models sits an infrastructure effort of historic proportions. For 2026 alone, Meta has committed over $60 billion to AI-related capital expenditure. This includes custom silicon, massive superclusters, and data centers consuming power at levels comparable to small nations. Some facilities are even paired with nuclear energy sources, underscoring how seriously Meta views long-term AI scaling. Global AI power shift. This signals a broader shift in the AI race. The next phase will not be won by clever prompts or marginal architectural tweaks. It will be decided by who can train, deploy, and iterate AI systems at planetary scale. In that contest, Meta is no longer a secondary player. For creators and developers, the implications are profound. Integrated AI tools could reduce production costs, accelerate workflows, and lower barriers to entry, especially in regions where premium AI services remain expensive. Advanced capabilities may soon live directly inside social platforms, without separate subscriptions. The vision of AI brings immense promise, but embedded within are significant risks and ethical tensions. Meta, once a champion of open source, has reportedly stepped back with its most advanced systems. This shift raises questions about who controls powerful tools and the future of collective accountability. At a social scale, powerful AI amplifies both benefits and harms, raising deep concerns. This brings urgent issues to the forefront, from algorithmic bias to data privacy and usage. The decisions made by algorithms can have profound impacts on entire populations and social structures. We must balance rapid innovation with responsible governance to ensure AI serves the common good. The conversation around AI ethics must remain as dynamic as the technology itself. As AI becomes a strategic asset, companies like Meta increasingly resemble nation-scale actors. Talent, energy, and compute now intersect with global policy and regulation. Avocado and Mango are not just products, they are instruments in a larger power shift. So is this another cycle of AI hype or a genuine turning point? Meta has avoided grand declarations, no claims of artificial general intelligence, no public victory laps. Instead, there is quiet confidence rooted in delivery, models built, systems tested, infrastructure deployed. The most important revolutions are not always announced with fanfare. Sometimes they are confirmed in passing, at a conference in the mountains. And by the time the world notices, the technology is already everywhere.